and it's not as complicated as Objective-C. So that's Swift. It was announced at WWDC this year, and pretty much everyone went mental for it. So within the first day, everyone started learning it straight away. And so I want to be able to show you guys how to use Swift, but also integrate it with SpriteKit itself. So I guess let's build a game. So what I have here is a project I have created using Swift and SpriteKit. And the way this works is that it starts off at this class level of game scene. So every game you create with SpriteKit always starts off with a game scene, and that is controlled through the game controller and the app delegate. So I guess the first thing we want to do is create some basic objects using the SpriteKit engine. So with Swift, we have this function called didMoveToView, and this is the initial view, initial function that is called when a view changes. So like with Objective-C, you have viewDidLoad. This function is always called first. So this is where you create all your initialization and all your objects and stuff. So the first step I'm going to do, so this code is actually pre-written, but I just commented all that. So just a lot quicker. So what I want to do is create a background of the game. So using this Create Manager that I've created. And what this is it's a structure. And what a structure can do is provide static functions. So then I can do this line of code of Create Manager .create background. So that's missing. So what this does is that it creates a background, which is here. So here, this is a SpriteKit node that is being initiated. So with this function, you just pass in the JPEG that I want to add into it. So if I look at my resources, this is basically the image I want to add, which is just a blue sky. It's just a static image. And that's done by using a SpriteKit node. So I use this thing called let, and that's because it's constant, technically. It's the same as a constant, but so let allows you to allocate the memory, and then it creates this SpriteKit node with bgsky.jpg and allocates into that, and that's a constant, and then it just holds on to that as memory. So that value can't be changed now. I position it in the middle of the frame using some of these standard functions that we already see in iOS already. And then I call parent.addChild, and that's basically adding the background SpriteKit node onto the parent scene, which is passed through this function. So that part, that lets you create the background itself, and then what I want to do with this game is have this parallax effect. So what I have is a few different layers of sprites that are going to be moving right to left, right to left. So what I've done here is create my own custom class, which is called parallax sprite. And what that basically does is inherits from SpriteKit node. I have a few different variables and constances that I initiated, which is the speed of the background that's going to be moving, the name of it, and then two SpriteKit nodes, which is the actual image of the background. So I have two because with parallax, you're scrolling two images at once. And once one actually goes off the screen, it just resets itself back to 0, and then it carries scrolling. So it's a seamless effect of just infinite scrolling. So in here, I override these two functions, because if I don't, it crashes for some reason. Well, that's an Xcode 6 board, I think. But then I also overload my own function where I pass in a name and the speed of the parallax calling, and a frame, which is the size of the frame. So in here, I just set up the textures again and initiate the SpriteKit nodes, and then add them to itself. And in here, it's just a bit of a defense saying if the speed is set to 0, there's no point in creating another image, so I'll just leave that null. So back in here, I have 4 different layers, which are going to be parallax. One's clouds, mountains, cloud 2, and a grass layer with different variables of speed. And then I add them to the parent scene again. So now they're all layered with a background. They got layer 1, layer 2, layer 3, layer 4. And then what I've done here, so with this create background function, I'm returning what we call a dynamic object. So this isn't a class or structure that is created. You can create it on the fly. So like in Flash, you can create objects like with your curly braces and then put your variable and your object variables in. So what I'm doing here is that what I want to return is an object that has a background of a SpriteKit node, and also an array of parallax sprites. So this initiates an array, and then what I return is this. So I've got the background, which means that it's using the SpriteKit node there, and then we've got an array of layers of parallax sprites. So once I've done that, so create manager will return that and add it to this reference here. And if I just initiate these. And then what I want to do is be able to update those over time. So with SpriteKit, you get this update function every scene, and this ticks on the clock depending on your frame rate. So it's normally about 60 frames a second on your mobile and around about 30 on the simulator. So what I'll do here is create a simple for loop, just iterate through those parallax sprites, and then call this update function. And all that update function does is moves that position X by that certain speed. And then when it gets to the end of the scene, end of the 0, it'll just reset it back. So yeah, let's run on this. So we have the static background there, which is that sun and that weird white thing in the middle. And then we've got these 2 cloud layers running at different speed, mountain and some grass. So now we've got the basic scene set up. I guess you want some sort of character or some sort of player you want to control. So yeah, again, in my create manager function, I have this create character function. And what this is doing is because SpriteKit allows you to do texture atlases and texture sprites and stuff. So I initiate it with this texture atlas here, call it character, and initiate a bunch of frames that the character is going to animate in. So in here, we should see some images. So we've got an image of one of the characters that we're using, and we've got 14 frames that he's going to animate in. And then once we've done that, we store the frames into an array, and create another SpriteKit node, and position it with a certain offset, so it's not directly in the center. Add it to the scene again, and then what we do is we use something called an escape action, which is the between an effect or movement or something that's going to happen during the game, like an animation. So what we've done with this SK action is to be doing this action forever, so we want to repeat it forever. And what we want to do is animate with textures. And this function basically accepts an array of frames. So we're taking frames and then we allocate a time per frame. So 0.1. So every 0.1 second it will just change the frame. And then we do player.run action and we pass in that action. And then that will run constantly. And we return the player back to the scene. So we run that, should have an animating bird. Or not. I don't know. There you go. So we've got an animated bird that's flapping. And by the way, this is not flapping bird. It may look like it, but. So I guess now we've got the bird sitting there, flapping away, and the parrot scrolling. We want to interact with the bird, make it do something. So one of the functions that every scene has is called touch began. So every time you touch the screen, I'm going to make the bird jump. It's still not Flappy Bird. It's going to be. So in this function, it's on touch began. We have the touches, what the number of touches you can receive with some sort of event. What I've done here is create a boolean, simple boolean saying if it's jumped or not. So if it's not jumped, then initiate this functionality. So it's saying here that grab any object. So this any object, like in Objective-C, is an ID. So it can be anything. It's just a reference. So what we're doing with the touches is get any object from the touches, and if we do have a touch, an interaction, then let's perform this action. So to make him jump, I'm using yet again just SK actions, doing a move to, so the player moves up on the y-axis by 200 pixels, and then the next action, once he reaches there, is the floor, so he resets himself back to his normal position again, and then on a complete action we run a block of code, which is just to set the jump back to false. So then people don't just spam, it'll just keep going on. So it'll just jump once and then fall back down and then stay there. So yeah, again we do run player, the run action, and we run it through using the sequence action. So we set up jump, then for, then complete, and then I set his jump is true. So we run that. See the number jumping. So after now we can jump, we can interact with the bird. Now there needs to be some sort of game mechanic to it. So you want to be able to do something with the bird. This bird must have an objective. So we're going to be collecting stars and not avoiding pillars. So what I've done is, so as the game runs, stars are going to appear and they're going to be scored across the screen, and then basically just have to jump to collect these stars, and every star you get gets a point. So we have this function here which is called update star. Call that. So what this is doing is that in the update loop, the game loop, it's increasing the star counter by 1 every frame. And what I'm saying that every 50th frame, I want to create a new star back in the 0. So yeah, again in the create manager, I have this, yeah again, create star, return a SpriteKit node, and it's just initiated with an image name star. What I've done here as well is used a random so that it can change its, make it the position of the random, but the X position is always off the screen. And then again, just add it to the parent jar. And then what I do here is that I will iterate through a list of the stars that I've created. So that there can be more than one. So we insert them into an array of SpriteKit nodes, and then loop through them and move them by a speed of 10 pixels per frame. And what we do once it reaches the end of the frame is it removes the star from the array and remove from parent, we'll remove it from the display list, and then Arc will do its thing and destroy it. Yeah, let's start. So we can jump up, we can't cut them yet. So the next part is to collect these stars, and the way this is done is using the physics engine that SpriteKit provides. The first step that I do is set up the delegate as a physics world and apply some gravity, which is going to be 0, 0. So no gravity. And yet, the line I commented out before was the physics part of the character. So every SpriteKit node, you can provide a physics body, and what this is doing is creating an SK physics body with the size of the player. So it's just a square of the size of the player. So anything intersects that is good. But with the star, what we're doing here is, again, doing the same thing, creating a body of the size of the star. But what we're doing here is bit masking. Contact categories. So what this is saying is that the star is the category of the star. Its collision can be start with character, and its contact testing is saying that the character can contact the star. So in our collision function, we have this function called did began contact, which is one of the functions that delegate stores, and it passes in this contact where we work out what the first body and the second body of the contact is by using bit masking. And what we do here is that if is to check whether the first body is the category of the star. So if it's a star, then we want to destroy the star. And what destroy star does is just removes it from the array list again and then removes it from parent. So when you jump, the bird collides with the star and just removes it from the scene. Also just carry on scoring across and then remove from the scene itself once it reaches 0. I guess the last bit is to add a bit of sound. Yeah, again, sound is also part of the action and effects. So all I'm doing here now is just creating a constant SK action, play sound file, and then start.cast. And then we just run that action. Yeah, the start is good. Not flat to go. So that's basically the simple game that I put together at the moment. This only took me about a day to build, only because I know SpriteKit. But the more important thing what I was doing was mainly trying to understand Swift. But yeah, once I started doing this and started coding in Swift, it was quite simple and it was quite bringing me back to my days of doing Flash development. And but yeah, all this sort of stuff is quite easy to learn, quite quick to learn if you really want it. So yeah, that's the game built, and here are some links that are quite useful when I started learning Swift. So Apple actually provide really good documentation, so you can read through that, and they actually had a book straight away for people to learn that I read on the tube. Then there's a load of people going like proper bonkers for it. So a lot of people have done cheat sheets. Matt Galloway has done his own little language highlights. And
that was great.
Right?
You needed to pay for that.
That one? Here you go. Not the highlights one. The highlights is free, yeah. But all the other Ray Wenderlet ones, yeah, you have to pay for. Other than that, there's this nice site, swiftdevs.co, which actually just has a lot of people's examples of Swift and what they're doing with Swift and different projects, and a lot of discussions happening about Swift. But most importantly, it's this link is my one, which is this exact game, so you can download that and start playing with it, tweak it, play with SpriteKit, play with Swift, and just change things around. But yeah, learning Swift it's good fun, it's easy, only because I know S3. But from Objective-C to Swift, I think it's doable. I don't see it being a problem. But yeah, it's a nice language to learn. It's quick, it's easy, and Apple says it's really fast. Yeah, thank you.
Why have you choose Struct instead of class?
Because okay, so the difference between a class and a structure. Structures are normally there for you to hold data and store data, so you don't really instantiate them. So when I use the structure, let me show you. Structure here, it's so that I can have static functions. If you use class, it doesn't allow that. You can't have static functions classes. Well, yeah, but structures are supposed to just be there for you to like store data and manipulate and create stuff like this.
I noticed on your demo, I noticed that the frame rate was rather low.
Yes, that's the simulator. It always is. No matter what, whenever you do SpriteKit or game, any sort of game development, never use a simulator.
Because it runs on CPU.
Yeah, it's half the speed. Well, that was actually 10 to speed, or 6 to speed. But always test on device and run on device, so that's the best way of doing game development. But even if you want to do it in Swift, you can't. It doesn't run on device at all. Because that's still in beta, so there's a lot of problems.
Wait, with us, it's like the stars. Would you consider having them reusable, where you can, rather than...
Yeah, that's the next part, maybe, is to store a certain amount and then reuse them. Yeah, I would.
Any other questions?
A couple. With your star emoji, what do you do about the update rather than as a SK action? And I was also wondering how you got around the issues with your parallel sprite, your subclass you get from SK sprite. Did that give you problems?
So first of all, the stars. So I didn't use SK action because I was using this as a demo. So I wanted to show a different varieties of doing ways of doing the game. But if I was to do it again, I'll probably use physics and then just add an impulse to it to make it move left and right. And then even the jump animation, I won't even have a 4. I'll just make it move up, but then just let physics deal with it and let it fall back down by itself. The other question was the parents, right? So when inheriting from SK SpriteNet.
Yeah.
I did have a few issues in terms of why I need to do this, which I have no idea why. Well, yeah, if you don't instantiate or write these functions, it does crash and it just doesn't compile. I'm not sure why you need to do that. No idea. If anyone else can tell me why. Why don't I need to write? I don't know why.
There's the chapters.
No more questions? So thank you very much one more time.
All the code's going to be available, is all available online now, and so you can download it and something. And people's already started to tweak it and change stuff. So have fun.
Thank you. So if you want, we can stay here. We still have beer, still have pizza, we can talk. If you have more questions, we will be trying to answer in front of everybody.